Hello everyone, welcome to week 4 of Algebra 2 online learning. This week we are going to be talking about hyperbolas. This will be our last section in our conics section. Next week we're going to move into sequence and series. And so this week we are going to talk about hyperbolas. We've talked about parabolas, circles, and ellipses so far. We're going to be using a lot of the same terminology from ellipses this week with hyperbolas. So the first fill in the blank is for the focus. And so each fixed point, F, is going to be inside the branches. All right, so the focus is always going to be inside the branches. And I'll kind of explain what the branches mean in a second because that might be kind of unknown at this moment. And so we're going to have two asymptotes. And so our vertices are going to be on our axes, and they are going to always be with letter A. And it's going to be either plus or minus in the X spot or plus or minus in the Y spot. But in this case, it's not going to be A or B. It's always going to be A. Now, for those of you that are not familiar with what a hyperbola looks like, these are two examples here. All right, so in this case, the branches are kind of the swoopy lines right here, curves. So they sort of look like two parabolas kind of butting up next to each other. And so our vertices are always these points right here where the branch touches the X, or here touches the Y-axis. Now the focus, when it says it's always inside the branches, the focus is right here. So it's kind of inside the swoop, not in the middle between the two swoops. It's inside the swoops. And the same here. These second two dots that I drew, those are the focus, or the foci. So they are inside the swoops, not in the middle between the two. So for day 1, all we're going to focus on is just graphing. We're not going to solve for the foci or for the asymptotes. That's going to be for the next day this week. Just today, we are going to focus on just graphing them. So the first step is we always need to get it in standard form. Now, if you remember from last week with ellipses, to get it in standard form, it has to be equal to 1. And in this case, this is equal to 225, so we got to do something about it. We got to get this equal to 1. And so to get this equal to 1, we are going to divide all three pieces by 225. This now leaves you with the equation x squared over 25 minus y squared over 9 equals 1. Standard form means it's always equal to 1, and that is what we want. That's what we got. So now from here, we are going to label a squared and b squared. Now, a squared in this case for hyperbolas is always first. No matter if that's x or y, does not matter. This first number is always a squared. So a squared in this case is 25. And that means that b squared is going to be 9. So if a squared is 25, that means that a is just 5. And b is just 3, because all we did was square root those. So once you have this, whatever your a is, that is always your vertice. All right, your vertices always come from your a. And part of your rectangle always comes from your b. All right, so vertices go with A, rectangle goes with B. Now, our vertices, we're going to go all the way straight up. And if we notice that's the X, so that means we're going to place our A where the X goes. And it's going to be plus or minus 5. And then we plug the 0 in the other spot. We follow the B up to where it goes, and that was y squared above it. So we're going to put this plus or minus 3 where the y goes in the y spot. And the other one, you always just plug a 0 in. So we are going to plot these points on the graph. So we're first going to start by plotting our vertices. So for this, we're going to put a dot on the x-axis at +5 and -5. So those are our vertices. Now, when I say rectangle, what I mean is we are going to create a dotted box. So we have ±3 right here. So we're going to just do like little dashes on where our rectangle is, just little dashes. We are going to create a rectangle between these 4 points right here. So we're just going to make like a little dashed rectangle connecting these 4 points that we came up with between the vertices and the rectangles. We're going to create a dashed rectangle. Once you have your dashed rectangle, this is where we're going to draw in our asymptotes. So our asymptotes for this case, you start at 0, 0, and you are going to draw out with dashed lines still towards the corner of the box. And we're going to do that for all 4 directions. It's going to be dashed. And you just make dashed lines from the vertex, from the origin towards the corner of the boxes. So we have our 2 asymptotes drawn. And now we just need to draw in the parabola. So, the double parabola to make the hyperbola. So you find your vertex right here, and with asymptotes, you can never ever cross them. So when we draw this, we're going to draw kind of swoops that go really close up to our asymptotes, but never touch. And so we have one on this side, and we have one on that side. So to sum this up, you want to first get this in standard form equal to 1. Your first number is always a squared, and your second one is always b squared. We found our a and our b just by square rooting. A is always your vertices, and b is always your rectangle. And so a, if you go all the way up, is underneath the x squared. So you take your a and plug it in the x spot. B was underneath of the y squared, so the 3 goes in the y spot. These are your vertices, so you put dots. With your rectangle, you put little dashes, and then you make a box connecting those 4 points. To make your asymptotes, you start at the origin, and you make your dashed lines going to the corner of your rectangle. Those are your asymptotes. Now to form your hyperbola, your 2 swoops, you start at the vertex, or your vertices, and you go towards the asymptotes, but never ever cross them. We are going to do this one more time. If you notice, for example, 2, it is already equal to 1. So we don't have to worry about dividing by anything. It is already ready for us. So we just need to start by identifying our a squared and our b squared. A squared is always the first number, always. So a squared is 16. And this means that b squared is 9. So if a squared is 16, a is 4, because we just square rooted it, and that means that b is 3. We square rooted that as well. So now we have to figure out our vertices and our rectangle. So vertices and our rectangle. So a was under the first one, which is y squared. So our 4 is going to go in the y spot. So we have ±4 in the y spot. Our b, if we follow it up, was under the x squared. So our 3 is going to go in the x spot. So ±3 there, 0 in the other. So we're going to start by plotting our vertices. So these are on the y-axis. So we put dots at +4 and -4. For our rectangle, we put little dashes on ±3. And we're going to form our rectangle by connecting these 4 dots. All right, so I formed my rectangle. Now the next thing is to draw our asymptote. So you start at the origin and you work your way out towards each of the corners of the rectangle we just created. All right, so now we have our asymptotes and we have our rectangle. All we have left to do is just graph our hyperbola. So you start at your vertices and you go towards your asymptotes, but just never ever touch them. And so there you go. That is your graph of your hyperbola. This was part 1 of this week. If you have any questions, please feel free to send me an email or reach out. But have a wonderful day.